Hello everyone, welcome to IIT Foundation classes. This is Srinivas, your maths faculty. Let us move on to the today's class, right? Today we are going to discuss the topic in divisibility rules, continuation part. Okay, so in previous class we have already discussed about the divisibility rules of 2, divisibility rule for 3, divisibility rule for 4, 5 and 10. Alright, same way, now we are going to take one more divisibility rule which is includes divisibility rule for 11. Okay, so and based on that let us discuss some of the problems which are given in the exercises. Okay, see here let us start with the concept based questions. First of all, the first question is, which of the following rule is divisible by 4? What is the rule we have discussed about the divisibility rule for 4? The divisibility rule for 4 is nothing but units place digit and tens place digit of a number, or else we can say in another way, that is nothing but last 2 digits of a number. What is that? Last 2 digits of a number zeros or multiples of 4. Last 2 digits of a number zeros are multiples of 4. That means last 2 digits must be zeros or multiple of 4. Then the entire number will be divisible by 4. Okay, na? That is the rule for divisibility of 4. Okay, let us see the options. The first option is last 2 digits of a number is divisible by 3. But according to the definition, it should be divisible by 4 or multiple of 4. So first option is incorrect. Let us move on to the second one. Sum of the digits is divisible by 4. Sum of the digits is not divisible by 4. Sum of the digit rule only applicable for rule 3 and rule 9. Okay? Yeah. Second option also incorrect. Option number 3. The last 2 digits must be divisible by 4. Yes, option number 3 will be our required answer according to the definition of a divisibility rule for 4 or condition of a divisibility rule for 4. Okay, so let us move on to the next problem. See here, the number which is divisible by 8, right? So rule number 4, rule number 25 and rule number 8. So I am discussing about rule number 4, rule number 25 and rule number 8. These 3 rules having a same similarities, some similarities are there. So let us discuss about that rule number 4, rule number 25 and last rule number 8. So rule number 4, just now we discussed that last 2 digits of a number, here last 2 digits of a number is either zeros or multiple of 4. Either zeros or multiple of 4 or divisible by 4. Then the entire number is exactly divisible by 4. Okay. Now coming to the rule number 25. Rule number 25 also last 2 digits of a number. Here also last 2 digits of a number zeros are divisible by 25. Divisible by 25 or multiple of 25 we can say. Here last 2 digits of a number is divisible by 4 or zeros. Here last 2 digit number or 2 digits of a number is zeros or multiple of 25. Then the number is exactly divisible by 25. And what about the divisibility rule for 8? The divisibility rule for 8, it is nothing but the last 3 digits of a number. How many? Last 3 digits. Last 3 digits means ones place digit, tens place digit and hundredth place digits. Ones, tens, hundreds. So these 3 digits of a number either zeros. All the 3 numbers can be zeros or multiple of 8. Or multiple of 8. Then the entire number is exactly divisible by 8. Now according to the question number here, the number which is exactly divisible by 8. Divisible by 8 means last 3 digits I have to check. So what are the last three digits? 650, 650. But we know 8 8s are 64, 8 80s are 640. 650 is not a multiple of 4, so option 1 is incorrect. Now coming to option number 2. Last three digits of this number is 644. 644 when you divide with 8. 6 8s are 64 or 6 80s are 644 remainder, which leaves the remainder 4. That means it is not exactly divisible by 8. Okay, because it is leaving the remainder 4. So second option also incorrect. Coming to the option number 3, 648. Yes, it is exactly divisible by 8 because 8 table 8 8s are 64, 0, 8 down, 8 ones are 8. So without leaving the remainder, 648, last three digits are exactly divisible by 8. That means last three digits are multiples of 8. Then we can decide that option number 3 is our correct answer. According to the definition of, or according to the rule of 8, divisibility rule of 8 is nothing but last three digits of a number is zeros or multiples of 4 are divisible by, multiples of 8 are divisible by 8, then we can say that the entire number is exactly divisible by 8. Okay, yes, this is the answer what we have to require. Let us move on to the next problem. Yeah, which of the following is a rule of divisibility 8? Rule for divisibility 8, just now we discussed last three digits of a number. Last three digits are nothing but ones place digit, tens place digit and hundreds place digit. Last three digits of a number are zeros or multiples of 8 or divisible by 8. Then the entire number is exactly divisible by 8. That means without leaving any remainder, that number can be divisible by 8. Okay. So let us go through the options here. Last two digits, it is not work out. We have to discuss about the last three digits of a number. Now here, second option also last two digits, so we can neglect the second option also. Coming to the third option, last three digits divisible by 8. Yes, which is exactly suitable. Option number 3 is our required answer. Okay, yeah. So let us move on to the next problem. Right. Which of the following number is exactly divisible by 11? Now here we should discuss about the rule for divisibility of 11. Divisibility rule for 11. So let us discuss divisibility rule for 11. Yeah. So whenever the number it is given, we have to check the even place digits and odd place digits of a number. Okay, na? Now the rule is sum of even place digits and sum of odd place digits yeah, sum of even place digits, sum of odd place digits and their difference is the difference is 0 or divisible by 11. 0 or divisible by 11, then the entire number is exactly divisible by 11. Okay, let me discuss the same divisibility rule with an example. Okay, so I am taking an example like 1443. I am taking an example like 1443 or 14432. Okay, now let us see the odd place digits and even place digits. Odd place digit means here at the right end, first digit, third digit and fifth digit. That means which I have underlined clearly the odd place digits from the right. Okay, right means units place digit. So their sum, I am adding the odd place digits are sum of odd place digits, which is equals to Yeah, sum of odd place digits. That is nothing but 1 plus 4 plus 2. So 1 plus 2 is 5 and 5 plus 2 is 7. Now let us add the even place digits. So sum of even place digits. Even places are nothing but remaining, which are the digits which are not underlined. So 4 plus 3. 4 plus 3 equals to 7. And their difference. Difference means we need to subtract both of them. Okay, 7 minus 7 is 0. So when we get the remainder 0, we can say that the entire number is exactly divisible by 11. So what is the rule? Sum of even place digits, sum of odd place digits, and their difference is 0 or multiple of 11. Then the entire number is exactly divisible by 11. Okay, this is the rule for divisibility rule for 11. Okay. Yeah. Now coming to the same question, let us try to apply the divisibility rules through the options. Okay. First option, I am just identifying the odd place digits. Odd places are nothing but 5. So 5 plus 3, 8. 8 plus 1, 9. 9 plus 3. 9 plus 3 is 12. Now I am adding all odd place digits. Now even place digits remaining. 6 plus 6, 12. 12 plus 1, 13. Okay, even place digits, sum is 13, odd place digits sum is 12. So 13 minus 12, which is nothing but 1. So according to the condition, the answer, the difference must be 0 or multiple of 11. Here answer is 1. 1 is neither 0 nor multiple of 11. Therefore option 1 is incorrect. Let us move on to the option number 2, odd places. So 1, 1 plus 3, 4. 4 plus 0, 4 itself. 4 plus 0, 4. I am writing here. Now even places. Even places means 5. 5 plus 1, 6. 6 plus 9. 6 plus 9 is 15. So 15 minus 4 is 11. See the difference, we are getting the multiple of 11 or divisible by 11. Therefore the option 2 is correct. According to the divisibility rule, the sum of odd place digits and sum of even place digits and their difference is 0 or multiple of 11. See the difference is 11. So 11 is multiple of 11 itself. So we can say that the option number 2 is correct option. So let us move on to the next problem. Right. The number which is exactly divisible by, the one number is given. So on the from the options we are having some divisibility rules. Let us check the number is divisible by which of the following numbers. Okay, what is the number here? 2836. Let us go through the options one by one. First option, which is divisible by 8 or not. What is the divisibility rule for 8? Last 3 digits of a number. Last 3 digits of a number, zeros or multiple of 8. Let me check the last 3 digits. 836. 836 is multiple of 8 or not? Let us check. 8 table, 8 nines are 72. So 8 tens are 80. Yes, we can take directly 8 tens are 80. Yes, 8 tens are 80. So 3 remainder, 6 carry down. So 8 table 36, we are not getting 8 fours are 32, remainder 4. So last 3 digits are not exactly divisible by 8. So option 1 is incorrect. Let us check the option number 2. What is option number 2? Divisible by 9 or not? What is the divisibility rule for 9? Sum of digits. Rule for 9. Sum of digits is multiple of 9. Sum of digits, multiple of 9. So let us try to add all of them. So 2 plus 8, 10. 10 plus 3, 13. 13 plus 6 is 19. 19 is not a multiple of 9. So option 2 also incorrect. Let us check option number 3. What is option number 3? We have to check the divisibility rule of 4 or not. That means the given number is exactly divisible by 4 or not. What is the divisibility rule for 4? Rule for 4 is nothing but last 2 digits of a number. Last 2 digits of a number is zeros. Last 2 digits of a number are zeros, or multiple of 4. Last 2 digits is 36. 36 is multiple of 4. 4 table 36 9 times. So that means the last 2 digits of a number is multiple of 4. The required option is 3. That means the answer, the given number is exactly divisible by 4. Okay. Yeah, please look into it. Let us move on to the next problem. Right. So which of the following number is divisible by 11? Yeah, just now we have discussed that divisibility rule for 11. What is the divisibility rule? Once again I am repeating that the rule is sum of even place digits and sum of odd place digits, and the difference is 0 or multiple of 11. Now I am checking the even place digits. Sum of even digits or even place digits, and let us check the sum of odd place digits also. Odd digits. Here even digits in the sense even place digits. Okay, now I am checking the odd places. I am go through the one by one option here. So odd places 0, 0, 0. First place, third place, fifth place. Sum of odd places is 0 itself. 0 plus 0 plus 0 is nothing but 0. Now even places 1 plus 1 plus 1 3. So 3 minus 0 is 3, which is not exactly divisible by 11. So option 1 incorrect. Let us check option number 2. Option number 2, odd place digits. Odd place digits 3 ones, 1 plus 1 plus 1 3. Second option, odd place digit option is 3. Even place also 3. 3 minus 3, which is exactly 0. According to the rule, the difference is 0 or multiple of 11. Yes, option number 2 is suitable for us. This is the correct option. Okay, so let us move on to the next question. Yeah. Which of the following number is divisible by 11? Again, 11th rule. Now, again I need to check even place digits, odd place digits. Okay, odd place digits. Yeah. Now, first option, even place digits and odd place digits. Odd places 5, 9 and 1. These three are odd places. First place, third place and fifth place. Now let us try to add 5 plus 9, 14, 14 plus 1, 15. Odd place digits, sum is 15. Now even place digits. Even place digits are only 5 plus 0. 5 plus 0 is 5. So we know that difference is nothing but larger number minus smaller number. So 15 minus 5 is 10, which is not a multiple of 11. So option 1 incorrect. Okay. Option number 2. Odd places 8 plus 4. 8 plus 4 is 12. Even place digits 5 plus 6. 5 plus 6 is 11, and the difference is 1. According to the rule, the difference must be 0 or multiple of 11. So which is also incorrect. Now let us go to the option number 3. Odd places 9 and 6. 9 plus 6 is 15. And the even places 7 plus 8. 7 plus 8 also 15. 15 minus 15, 0. So that means option number 3 is incorrect option. Sorry. Option number 3 is correct. Okay. Because the difference is 0 or multiple of 11. We got the zeros now. So we can decide that the given number is exactly divisible by 11. Okay. Move on to the next question. Right. The number which is nothing but 4,32,650 is not divisible by. Again, options are given. 4,32,650 is the number which is not divisible by following options. Let us check the options one by one. The first option is what? 2. What is the rule number 2? The last digit or units place digit of a number is 0 or multiple of 2. Then the number is exactly divisible by 2, or 0 or even number also we can say. The last digit of a number or units place digit of a number is 0 or even, then the number is exactly divisible by 2. See, last digit, yes, last digit is 0. That means the entire number is exactly divisible by 2. 2 is the one of the option, but the question is given which is not divisible. That means first option is not our answer. Okay, let us check 5. Second option is 5. That means rule 5 we need to check. Rule 5, what is the rule 5? The last digit or units place digit of a number is 0 or 5. Here units place digit is 0 or not? Yes. That means the given number is also divisible by 5. These two numbers are divisible by, so that means the given number is divisible by 2 as well as divisible by 5. So these two are not our required answers. Let us move on to the third option. Option number 3 is rule for 10. What is the rule for 10? Last digit is 0. Yes, last digit is 0. This is also exactly divisible by 10. The given number is also divisible by 10. That means 1, 2 and 5 exactly divisible by, that means these three rules are satisfied, but the option is which is not exactly divisible, that means 4. Option number 4 is our required answer, because what is the rule number 4? Rule number 4 is nothing but last two digits of a number. Last two digits of a number is zeros or multiple of 4. So last two digits. What are the last two digits here? 50. 50 is not a multiple of 4, because 4 12s are 48. 4 13s 52. So 50 is not a multiple of 4. So required answer is 4. Okay? Yeah. So let us move on to the next problem. Yeah. Which of the following number is divisible by 4 but not 8? The given number should be divisible by 4 but not 8. That means we need to check both of the rules. What are the rules? Rule number 4 we need to check, and rule number 8 also we need to check. What is rule number 4? Rule number 4 is nothing but last two digits. Last two digits of a number, zeros are multiples of 4. Zeros are multiples of 4 or divisible by 4. Then the entire number is exactly divisible by 4. Now what is rule 8? Rule 8, we need to check last 3 digits. Rule 4 only last 2 digits, but rule 8 is last 3 digits. So last 3 digits of a number, last 3 digits of a number is, last 3 digits of a number are zeros or multiple of 8. Multiple of 8, then the entire number is exactly divisible by 8. Okay, according to the condition, the given number should be divisible by 4 but not 8. Okay, let us check. Last two is 64. 64 is multiple of 4 or not? Yes. 4 tables 16 times. 4 16s are 64. 64 is a multiple of 4. So, which is exactly divisible by 4 table. I am going to check all the fourth rule first. Okay. So, which is divisible by 4? Yes, first one is divisible by 4. Now, second option 64. Yes, it is also divisible by 4. Third option, last two digits are 40. Yeah, it is also divisible by 4 because 40 is multiple of 4. 4 times are 40. Last two digits. See, all 4 options, that means all 4 given numbers are exactly divisible by 4. Okay, but it should not be divisible by 8 is our required answer. Let us check the 8 rule. 8 rule means what? Last 3 digits of a number. 664. 664 is divisible by 8 or not? Let us check. 664 is exactly divisible by 8 because 8 8s are 64. 2 remains 4 down. 8 3 is 24, remaining 0. So last 3 digits is divisible. So which is also divisible by 8. Here 446. 446. That means last 3 digits is divisible by 8 or not? Let us check. See, 8 table, 8 5s are 40. 6, 4 remainder, 8 8s are 64. So which is exactly divided by 58 times. The second option also divisible by 8. That means first 2 options are not our solution. Okay, third one, 940. 940 is divisible by 8 or not? 8 ones are 8, 14, again 8 ones are 8, yes, which is not exactly divisible by 8. So this is our required answer. Okay, na? Yeah. So among the four options, option number 3 will be the correct answer according to the question. That means the given number, the options, among the four options, one number is not divisible by 8. It is divisible by 4 but not divisible by 8. Okay, right. So let us move on to the next question. Yeah, let us move on to the next problem, children. So here multiple choice questions are given. The first question is, if the number 9x8071, so which is nothing but 6-digit number, so among the digits, one digit is missing. So in the place of digit, there is a variable is presenting here which is nothing but x. And the question is given that is exactly divisible by 11. That means this entire 6-digit number is divisible by 11, then the value of the digit x is. That means we need to find out the value of x. Okay. So here there is a clue for us, that is nothing but the given number is divisible by 11. So we can use divisibility rule of 11. What is the divisibility rule of 11? Sum of odd place digits and sum of even place digits and their difference is zeros or multiples of 11, then the entire number is exactly divisible by 11. That is the rule for 11. Am I right? Yeah. Now let us try to check the sum of even place digits and odd place digits. Sum of even digits. Even digits in the sense even place digits. Okay, now I am checking the even digits. So here even digit is nothing but 7, 8 and 9. Even places from right side towards left, from right to left side. 7 plus 8, 15 and 15 plus 9. 15 plus 9 which is nothing but 24. So we got the even place digit sum is 24. Now let us check odd place digits. Let us check the sum of odd place digits. So odd places are nothing but 1, 1 plus 0, 1 and 1 plus x is nothing but 1 plus x. And difference. Difference means 24 minus 1 is 23 minus x. Okay, na? So difference we got 23 minus x. But we know according to the divisibility rule, the difference among the sum of even place digits and sum of odd place digits must be 0 or multiples of 11. Multiples of 11s are nothing but 11, 22, 33, 44, like that we can take up to 99. Okay, na? Yeah. So let us take difference can be 0 first. It can be 0 or it can be multiple of 11. Multiple of 11 means 11, 22, 33, like that. Okay, let me try here. So I am transposing plus 23 towards right side. It will be minus 23. Both sides minus cancel. Then x value is 23. We got x value 23. But is it true or not? Definitely not, because the x is have to taken as a single digit number. X must be single digit number, but it is double digit we got. So we cannot take answer as 0, difference as 0, which is not exactly suitable or exactly not fit to the value of x. Okay, let us take 11. Again 23 transpose that side becomes minus 23. 11 minus 23 which is nothing but minus 12. So again x value is 12, 2-digit number, which is also not suitable for us because x must be single digit number. Next, coming to here, 22 minus 23. So 22 minus 23 is nothing but minus 1. So x value is 1. Yes, which is suitable for us. Therefore, the required answer for x is 1. So option 2 is the correct for us. Okay. So let us move on to the next problem. Yeah. Again, missing letter, missing digit. The number 75x we can consider as 75x as 3-digit number. 75x is 3-digit number, is divisible by 4. What is the divisibility rule for 4? The divisibility rule for 4 is last 2 digits. The divisibility rule for 4 is last 2 digits of a number. Last 2 digits of a number are zeros. Both the numbers can be 0 or multiple of 4 or divisible by 4. Okay. So according to the definition, and still the question is not yet end, then the smallest number replaced by x. Smallest number replaced by x. Okay. Now let us take the x value can be 0, 1, 2, 3, 4 up to 9. There are 10 chances of x value can be any one of the digit in the 0 to 9 digits. I am taking x value 0 once. That means 50. According to the divisibility rule, last digit 2 digits must be divisible by 4. 50 is not a multiple of 4. So we cannot take 0 in x place, in the place of x. Let us try with 1. 751. 51, last 2 digits. 51 is also not a multiple of 4. So 1 also not having chance for us. Now 752. What about 52? 52 will be the multiple of 4 or not? Yes, 52 is a multiple of 4. That means 52 is a multiple of 4 exactly 13 times. 13th multiple of 4 is nothing but 52. So x can be 2. 2 is one of the chance. And 753, 53 is not a multiple of 4. 54 is also not a multiple of 4. 55, not a multiple of 4. 56, yes, it is a multiple of 4. So among these, 752, 756 are the chances to become x value as 2 and 6. Then 7, 8, 9 also won't work out. But that means in the place of x, there are 2 chances. X can be 2 or 6. According to the question, the smallest number replaced by x, smallest number among 2 and 6 is 2. Our option is 3. Third option will be the right answer. Okay. Yeah. Coming to the question number 3. Which of the following numbers is divisible by 11? Divisible by 11. Following numbers are divisible by 11. So 11th rule. Sum of even placed digits, sum of odds placed digits, and their difference is 0 or multiple of 11. Okay, let us go through the numbers. First, I am checking the even places, odd places for all the numbers. So even digits I will write. Okay, here sum of odd digits. Yeah, sum of even digits, sum of odd digits. Yeah, first number. Odd places. So 1, 2, 2. 1 plus 2 is 3, 3 plus 2, 5. So sum of odd places we will get 5. And even places, 8. 8 plus 3, 11. 11 plus 5, 16. 16 minus 5 is 11. Yeah, first one is the right answer. First one is the right answer. Let us try with the second option also. Odd places, 5 plus 7, 12 plus 8, 20, and even places 6, 6 plus 9, 15, 15 plus, yeah, this is also multiple of, because difference is 0 we got. This is also multiple of this, the second number also exactly divisible by 11 according to the divisibility rule. Okay. So third option 1 and 2, yes. According to the question, we should use the option number 3 because the first number, the first option, in the first option, the given number is exactly divisible by 11 and second option also exactly divisible by 11. So first option correct, second option correct. So both 1 and 2 are the answers. 1 and 2 are the options are nothing but 3. Okay. So let us move on to the next problem. Yeah, which of the following number is divisible by 4? What is fourth rule? So I'll write the fourth rule here. Last two digits of a number. Last two digits of a numbers, zeros are multiple of 4. Okay, let us check last two digits. 84 is multiple of 4. Yes, exactly. So option 1 only the correct answer. Let us check here. 06. 06 means 6. 6 is not a multiple of 4. Option 2 incorrect. 07. 07 means 7. It is not a multiple of 4. 22 is not a multiple of 4. Only option 1 is the correct one for us. Okay. Move on to the next problem. Question number 5. That is given that the number 3,11,113 is exactly divisible by. There are 4 options are given. The first option, which is divisible by 11 or not, we need to check, or 4, 8 and 2. So I am coming from the reverse. Last digit according to the option 4, which is given 2. That means we need to check the divisibility rule for 2. What is the divisibility rule for 2? Last digit is 0 or even number. So last digit is odd number. So the given number is not exactly divisible by 2 table. Now coming to 8. Last 3 digits of a number must be multiple of 8 or zeros. Here 113 is multiple of 8. No. 8 table 113 won't come. That means 113 is not a multiple of 8. So option 3 also incorrect. Option 4. Last 2 digits are multiples of 4. No, 13 won't get in 4 table. 13 is not a factor of 4. 13 is not a multiple of 4. So option 2 also incorrect. So only we are having option 1, sum of even place digits. What are even places? So yeah, even places, odd places. I am checking odd places. 3 plus 1 4, 4 plus 1 5. Sum of odd place digits is 5 and even places remaining 1 plus 1 2, 2 plus 3 5. So this is also 5. Difference is 0. So according to the definition of divisibility rule, the condition for the divisibility rule is sum of even place digits and odd place digits and their difference is 0. Yes. Option 1 is correct. Which is exactly follows the divisibility rule for 11. Yeah, coming to the question number 6. Which of the following number is divisible by 8? What is the divisibility rule for 8? The last 3 digits. The last 3 digits of a number. Zeros are multiples of 4. Let us check. Last 384. 384 is multiple of 8 or not? Yes, 384 is a multiple of 8. So 8 table, 8 4s are 32. 6 remainder 4 down. 8 8s are 64, remainder 0. So 48 times can be cancelled here. Last 3 digits are multiples of 8. So option 1 is correct. So we now need to check the remaining options. Okay? Yeah. So let us move on to the next problem. Which of the following is divisible by 8? Again, divisibility rule for 8. What is the divisibility rule? Last 3 digits. So last 3 digits of a number. Zeros are multiples of 8. Zeros. Last 3 numbers are zeros or multiple of 8. Then the entire number is exactly divisible by 8. Let us check. Last 3 digits. 280. 280 is not a multiple of 8 because 8 table 8 3s are 24, 8 30s are 240. But here 280 we won't get in 8 table. So first one is incorrect. 205. 8 table 5 won't come. Okay, 8 table 5 won't come. So option 2 also incorrect. 782. Is it possibility of correcting the option here? 782, 7 table, yeah, 8 table, 8 9s are 72, so 62. So 782 is not a multiple of 8. Option 3 also incorrect. Option 4, 278. Let us check. 278 is multiple of 8. 8 3 is 24. No. Let us check. Option 3 again. 8 table, 8 9s are 72. Yeah, all options are incorrect actually. So there must be a change here. Let us try to change the option number 4 as 288. Option number 4 as 288. Then we will get exact answer. Option number 4 will be correct. Change the option as 48,288. You will get the answer. Okay. So let us move on to the next problem. Right. So let us go through the next problem, children. So problem number 8. The number which is given that 3, 4, 5, 6, 7 and x. So there is a 6-digit number which is divisible by 4. That means the entire number is exactly divisible by 4, and then the value of digit x. So we need to find out the value of digit x. So let us check the possibilities of x first. First of all, the possibilities of x are nothing but 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All single digit numbers from 0 to 9. There are 10 possibilities of having x value. So there are 0 to 9, 10 possibilities. So that means among the 10 possibilities, we need to apply the condition also. What is the condition is? The number is divisible by 4. What is the divisibility rule for 4? The divisibility rule for 4 is nothing but last 2 digits of a number. The last 2 digits of a number, zeros or multiples of 4. Zeros or multiple of 4. Okay, the last 2 digits cannot be zeros, because here already one of the number is 7. So the 2 digits cannot be 0. So only we are having option as multiples of 4. So in the place of x, I am just replacing one by one digits. All the digits I am replacing here. 70, 71, 72, 73, 74 like that. So among them, what are the possibilities? What are the numbers are exactly divisible by 4 tables? 70. 70 is a multiple of 4 or not? 70 is not a multiple of 4. Therefore, x cannot be 0. 71 is also not a multiple of 4. 72. What about the 72? Yes, 72 is a multiple of 4. Next, 76 is a multiple of 4. So remaining 73, 74, 75. So these are all not a multiples of 4. So we are having only two options. X can be 2 or 6. X can be 2 or 6. Let us check the option here. Among them, 6 is not given. So 2 is the correct answer. So first option is correct. So let us go through the second question. That means next question. Which of the following number is divisible by 4? Again, fourth rule. What is the fourth rule? Last 2 digits of a number. Last 2 digits of a number must be multiple of 4. Now check the last 2 digits here. 26. 26 is not a multiple of 4. 4 6 are 24. 4 7 is 28. But 26 is not a multiple of 4. Therefore, this entire number is not exactly divisible by 4. 58. 56 is multiple but not 58. So, which is also not a correct answer for us. Now, third option, 24. Yes. 24, last 2 digits are 24. 24 is multiple of 4. Therefore, the required answer is option number 3. So, let us move on to the question number 10. Which of the following number is divisible by 4? Which of the following number? Same rule. Again, last 2 digits we have to check. Last 2 digits. So, according to the divisibility rule, the last 2 digits of a number, zeros are multiples of 4. 2 digits are multiple of 4 or divisible by 4. Multiple of 4 or divisible by 4. Therefore, the entire number is exactly divisible by 4 table. Now, 69 is not a multiple of 4, because in 4 table odd number won't come. Now, coming to 34. 4 8s are 32, 4 9s are 36, but 34 is not a multiple of 4. So, second option also incorrect. 46, 4 11s 44, 4 12s are 48. So, 46 is not a multiple of 4. Here 32, yes. 32 is a multiple of 4. Therefore, the entire number is exactly divisible by 4 table. Okay. So, let us move on to the problem number 11. There is a 6-digit number. There is a 6-digit number, it seems, and sum of the digits of even places. Sum of even place digits, which is given that 9. Sum of even place digits are 9 and sum of the odd place digits is 20. Sum of odd place digits is 20. Then the number is, such type of numbers are divisible by, and while you are observing here, sum of even places to sum of odd places. This condition is in the rule of divisibility rule for 11. This condition is being a part in the divisibility rule of 11. What is the divisibility rule of 11? Sum of even place digits, sum of odd place digits and their difference. Difference means larger number minus smaller number. 20 minus 9 is nothing but 11. So difference is 0 or multiple of 11. Yes, difference we got 11. Therefore, the entire number is exactly divisible by 11. That is the divisibility rule for 11. Okay. So let us move on to the next problem. Yeah. The last divisor of 1,61,051. 1,61,051. The last divisor, that means if you take any number, that number can be exactly 2 factors prime number, more than 2 factors are composite numbers. Yes, we know the discussion about the prime numbers. We had the discussion about the prime numbers and composite numbers in previous classes. And here asking about the last divisor. What about the last divisor? Obviously the last divisor can be 2 chances. First one is 1, second one is itself. But the question is given other than 1, therefore the number itself is the last divisor. The last divisor of any number is itself or 1. Okay, no? So here question is given other than 1 means itself. Therefore the answer is 1,61,051 is the answer for itself. So that's it for today, children. Thank you one and all. Have a nice day. Bye bye.